Completing the square is an important tool. It's used not only for finding vertices, but many other things, especially in calculus. In here, complete the square, so the first thing to do is make sure that this is just x squared. Divide both sides by 3. So y divided by 3 is equal to, then divide this by 3, we've got just x squared. Divide this by 3, we've got a 5x. And then leave some space and put the negative 8 divided by 3. Why do we need the space? Well, what we're going to be doing is taking this polynomial, once we figure out what number goes here, and factor it into a perfect square. But we need to figure out what number goes here. We'll take the b term, 5, over here on the side, 5, cut it in half, and square it. So 25/4 is the number that needs to be in here. So add in 25/4. But you can't just add in a number without balancing for that. So what you can do is subtract it from the negative 8/3. So in other words, we're borrowing 25/4 from this guy, and we're putting it over there. Remember to copy down y over 3. Don't lose track of that. Now this part, these first 3 terms, can be factored into a perfect square. That's why it's called completing the square. There's the square part. The completing part is this 25/4. And this can be factored into x plus, well, with this you can think, what would I square to get to 25/4? Or you can just look over here and see it's 5/2. And then over here I need a common denominator, which is going to be 12, so I need to multiply this by 3 on the top and the bottom, and this one by 4 on the top and the bottom. And they're both negative, so the result is going to be negative something 12ths. And there's negative 32 and negative 75. Negative 32 and negative 75, negative 107. And then multiply both sides by 3. So it's going to be y equals 3 and then x plus 5/2 squared. So the 3 just sits in front. And then over here, reduce a 3 divided into a 12 is 4. And then for the vertex, the x value is going to be the opposite of what's in parentheses, so negative 5/2. And the y value is going to be this one over here, the negative 107/4. And then I'm very curious to verify, see if I got that correct. So graph the original function, 3x squared plus 15x minus 8. And then zoom standard. Well, the vertex is way down here, so I need the window to go farther down, let's say negative 25. Almost made it. How about negative 30? All right, there's the vertex down there. And then I want to verify that it's negative 5 divided by 2. So trace negative 5 divided by 2. That's correct. And supposedly this is 26.75. Let's see. 107 divided by 4, 26.75, and we've got the negative, and so that's the vertex.